Hello everyone, welcome to today's video. So we have a nice live stream planned. We have a Falcon 9 rocket carrying a new Pathfinder satellite that's going to go around the moon. So it's going to be pretty sick. I'm going to quickly move my drink out of the way. So yeah, it's going to be quite cool. We are bottle now sits in the way. Typical. It's always typical. So excuse me if I'm a bit sweaty. Me and Rich just been playing on the old PlayStation, getting some cool videos going. Some very close calls on the things, but yeah. So we have this rocket. We have a Falcon 9, as you can see right there, plain and simple. It's now doing its T-20 whatever that's called. I can't remember what it's called. What's it called? Purge. They're purging the lines. So yeah, they've got that. I'm just gonna zip past. Whoop, look at that. It's almost like you didn't see it. We're going to find out some information about this rocket. So it's the KPLO mission, and the KPO stands for, yes Rich, you are first. So this is going into a ballistic, let's change it over for you guys to see. So this is going into a ballistic lunar transfer orbit. So, see, look, they're getting here. The webcast will end 15 minutes. Oh, no, it was. Oh, don't listen to me. I thought it was talking about ending. Nah, mine. Hello, Fats. You two behave, because Nightbot will kick you. So, this booster has flown quite a few times by the looks of it. But yeah, so the So yeah, we're now loading the locks into the second stage, which is awesome. So how is this one gonna go? So it's not boost back burn. Right, so landing and deployment, here we go. Okay, so there is a bunch of... So does it does the... Yeah, admittedly Martin, Rich was first. He was watching even before it started. I was making releasing Lucas from my body. Who's that to, Mark? Me or Rich? Oh, so okay, whatever. Well, whatever. Rich was the first one to comment. So this is doing like different stage of burns. So that's the... Okay, that's quite cool. So it's pretty cool. Both of you. Yes, we are 12. But yeah, we're gonna have quite a nice rocket launch. We are still waiting for SpaceX to start their stream as usual. But if I can find... I'm trying to figure out what the name of... it's Korean something. That's it, Korean Pathfinder. Yeah, it's in the title. I'm literally looking at these two screens here. It's right here. Korean Pathfinder Lunar Orbiter. So basically this is basically a little satellite that's going to go round the moon to test their... So if I get my microphone, I can easily show this now. So what Apollo missions did, they went around like this. So imagine we're looking at the moon. This is what they do. Humming-Song's rocket. But what Artemis are doing, and NASA, their SLS, they're going like this. So they're going close and really far away. Close and then really far away. And as everyone's loving the name, there's a reclin... Oh, I can never say it. I'm not even going to say it. It's basically one end is really high away from the moon and the other's really low. That's basically it. So they're all testing these different ways, and I think this one's coming sort of a little bit smaller of an orbit around the moon. So yeah, that's basically what's going to happen with this rocket, or this type of... SpaceX is live. Yes. Right, shall we have a look? SpaceX. I can't spell SpaceX. Oh, hey, we are live. Okay, right. I'm gonna chuck the... Oh, we got Andy Tran. Right, that's 4K.
72nd overall launch and the 34th launch of this year. Our webcast
I'm gonna find out how to spell it first, Mark.
Korea Pathfinder Lunar Orbiter mission headed to a ballistic lunar transfer orbit, which we'll get to a little bit later. For background, KPLO was given the Korean name of Tanuri, which is a combination of two Korean words, Tair, which means moon, and Nurida, which means to enjoy. KPLO will also be South Korea's first lunar orbiter, and it's been in development by the Korea Aerospace Research Institute, or KARI, since 2016. On board the lunar orbiter are a total of 6 science and technology payloads from renowned organizations such as the Kyunghee University, the Korea Institute of Geoscience and Mineral Resources, the Korea
for some reason.
Space Science Institute, and NASA. On today's mission, in addition to KPLO, we have another special rideshare on board. If you've been following SpaceX, you may remember that we launched a Tesla Roadster as the payload for our Falcon Heavy demonstration back in 2018. The early supporters of Tesla provided photos that were etched into a mosaic, and some were given the opportunity to put together a digital time capsule, both of which are now bolted onto the second stage. Following separation from the first stage, the second stage will continue to travel through time and space with a mosaic and time capsule.
That is pretty sick.
Although we may not see views of this right after the fairing separates, we'll keep an eye out for it throughout the mission and try to point it out if we do see it. For now, let's learn a little bit more about the Falcon 9 launch vehicle. Falcon 9 is a reusable two-stage rocket designed and manufactured by SpaceX for the reliable and safe transport of people and payloads in Earth
I don't know.
orbit and
What do you
beyond.
call him?
Starting from the bottom of the vehicle, we have our first stage, which is the largest part of Falcon 9. And as the name suggests, Falcon 9 has 9 Merlin or M1D engines at the bottom of the first stage.
Transit. Oh, that's terrible.
Various orbits in space.
Oh,
the dark slit that you
mine.
see around the lower part of the first stage are remnants from its 5 previous launches. After lifting off for the 6th time today, we'll attempt to recover our first stage again on our drone ship that you see on screen. That one is
So this is the... Oh, look at that weather. Look at that. It looks like a bit of a rain.
We have the black carbon fiber interstage that connects the first and
Yeah, this is what it's
interstage has
called.
pneumatic
Hang on,
pushers to allow the two stages to separate, and also houses the Merlin vacuum engine on the
Move
second
me out the
stage
way.
that will take our payload
There you go.
into its desired orbit.
So a near
At the very top
rectilinear
of Falcon 9, we have the payload
halo
fairing.
orbit.
It is made up of 2 carbon fiber pieces that come together.
That's how
to
you
encapsulate
say it, at
the
least.
KPLO payload and protects it until we reach the vacuum of space. Once in space, the 2 pieces will separate from each other and begin their
I
journey.
like this little graphic. That's pretty cool.
Similar
What
to
they've
our first
done.
stage, we'll also recover the fairing halves to fly again in the future. So that was a little bit about Falcon 9, our launch vehicle. Now let's learn more about the mission at hand and the payload flying on board Falcon 9.
So where is this? Which pad is it? Oh. Oh, we've got a cool little intro. Oh, this is Slick 40.
KPLO is an acronym for Korea Pathfinder Lunar Orbiter, and its Korean name.
Yeah, they didn't really have a very
It is South
very
Korea's
unique
first lunar orbiter
name for it.
and has been developed since 2016. It will be launched in early August 2022. It has a total of 6 science and technology payloads and will travel in DLT orbit for about 4.5
So
months.
Slick 40 is the one.
And then enter the
There.
lunar mission orbit
Okay,
at
right.
the end of December 2022.
Right, this is Slick 40 here. And then
2 solar panels. A high gain antenna
that's
and a
39A.
magnetometer are deployed for flight configuration in space.
No, that's where basically it is. That's where Starship will launch from. That pad right there.
Wide-angle polarimetric camera, POLCAM, gamma-ray spectrometer, KGRS, magnetometer, KMAG, delay-tolerant network,
Rectilinear.
DTNPL,
Yeah, rectilinear.
permanent shadow region camera from NASA, ShadowCam.
Oh, shadow
Danuri
cam.
is launched toward the sun, not the moon.
Oh,
It
okay.
will travel for about a month as the sun gravity pulls it. Finally, it will reach around the L1 Lagrange point, which is the point of equilibrium under the influence of the sun and the Earth's
Oh,
gravity.
okay. It's going to the L1.
After that, when the TCM burn is started to make sure it can reach the moon on the desired date, it will be pulled by the gravitational force of the Earth, the moon, and the sun to travel several million kilometers. Then, it will naturally approach the moon that is revolving around the Earth. After entering the
I
lunar
love
orbit,
it.
Danuri will maneuver
Yeah, there you go.
several times to reduce the orbit altitude. Finally, it will reach the mission altitude of 100 kilometers in polar near-circular
Is that
orbit
it?
for 6 payload missions.
So, it's going to end up going
Is a high-resolution
polar,
that has the mission to take images of the lunar surface.
whatever. I can't speak today. But it's going up and over like this.
Is composed of 2
Instead of
cameras slanted by 45
like that.
degrees each to take polarimetric images of moon surface. The gamma ray spectrometer is used to make a map of 5 major elements on the entire surface of the moon.
Yeah, they're basically just trying to find out what's on the moon.
To measure the strength of the magnetic field, which is invisible. Shadow cam will record images of the permanently shaded regions around the poles of moon where no sunlight can reach.
So it's that'll be infrared then, won't it?
DTNPL will conduct the world's first communication test on the moon.
That's mad. They're actually going to communicate back and forth.
Space research and development will experience a very important turning point thanks to Danuri.
Nice.
It is a very significant milestone in the history of Korean space.
That's me reading off a script. Just
Danuri is just at the beginning.
looking at it.
And if we are all determined and committed to technology development for space travel,
Today's drink is strawberry flavoured water from Tesco.
and so on in the near future.
I've drunk almost a whole bottle. Me and Rich been on PlayStation for a couple of hours.
As we saw in the video, KPLO's final destination will be the moon, or a lunar orbit to be more precise. Traditionally, if we wanted to send something to the moon, we would launch the payload into a lunar transfer orbit or a trans-lunar injection orbit. A lunar transfer orbit has an apogee altitude of approximately 385,000 kilometers, which is roughly the distance between the moon and the Earth. To support this type of launch, our teams would select a launch window that would allow the payload to meet the moon when it reaches apogee, and at that point it would use its own propulsion to get into an orbit around the moon.
Yeah, that's
Although
mad.
this is the fastest approach, it also requires a significant amount of fuel for the payload to get into its final orbit around the moon. KPLO will instead be launched into a ballistic lunar transfer orbit, which will require KPLO to be launched into a much higher orbit of about 1.2 million kilometers, which is about 3 times higher than the lunar orbit we just saw. At this height, the gravitational pull from the sun starts becoming dominant compared to that of the Earth. The payload will then fire its thrusters to put itself on a return trajectory towards Earth, and this will bring it closer to the moon, where it will once again use its thrusters to maneuver into a lunar orbit. The ballistic lunar transfer approach takes much longer.
When's the
to get
next
into the final
Falcon
lunar
Heavy
orbit,
launch?
but
That
it
is the
requires
thing.
a lot less fuel from the satellite. So turning our attention back on screen, we see that the strong back, which is that gray structure next to the vehicle, it should begin to recline away from Falcon 9.
Strong back recheck in progress.
You can see on screen that it is indeed reclining to its pre-launch position. It is part of a larger structure called the Transporter Erector, also known as the TE. The TE's job is to roll the rocket out to the pad and raise it to the vertical launch position that you see on screen. It also routes the vehicle's fluids,
It's crazy. It's going to take.
and telemetry,
Yeah,
from the ground
and it's literally like a 2-day journey, like normally.
on internal power and clears the path.
But because they don't want a lot of fuel in it,
Back will continue to recline away from
they're going to do it
Falcon 9
this
as
way.
we get closer to T0 to provide clearance for Falcon 9 to lift off.
Stage 1 LOX load is complete.
Our team in Florida began loading propellants at the T-minus 35-minute mark, and we are
Alright,
nearly
where's
full on
Falcon
both
Heavy?
stages. Falcon 9's first and second stages use the same 2 propellants. We use RP1, or Rocket Propellant 1, as our fuel, and super-chilled liquid oxygen, or LOX, for our oxidizer. In addition to these 2 propellants, we also use the chemical TTEB, or triethyl aluminum and triethyl borane, as an ignition source. The combination of RP1 and LOX is what makes the rocket go, but it's TTEB that sets the match to the propellant mix. So right now the weather looks like we're just a 10% chance of violating launch weather requirements.
Well, that's good. Only 10%
The launch vehicle,
today.
satellite, and range are all looking good for an on-time liftoff today at 7:08 p.m. Eastern Time.
Chuck that down there. Oh man. Here we go. Come on. Oh, I've got to turn my. Here we go. Here we go. Here we go.
That call out for stage 2 LOX load complete. That means that the vehicle is fully fueled on both stages and ready for liftoff just 90 seconds from now.
Oh, and pole. Right, okay, the pole didn't work.
We're starting to see some clouds form around Falcon 9 and hearing some hissing. That is normal and expected for us at this stage in the countdown. So things continuing to look good for non-stop.
There we go. Right, I've put another quiz in there, poll in there, because for some reason mine just decided to be stupid.
Falcon 9 is in startup.
Falcon 9 is in startup.
Which means that both stages are beginning to pressurize for liftoff.
Here we go, guys.
LD is go for 2 and 24.
Launch director has given the final go. All systems are go for launch of Falcon 9 with KPLO.
First fun. Alright,
2
come.
minutes, 30 seconds, stand by for terminal count.
Alright, here we go.
Eleven,
11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. I love the echo.
ignition,
There we go.
and liftoff.
Oh, that's gorgeous. Print screen.
Vehicles PG downrange. Stage 1 propulsion is nominal.
Nice. Here we go. We're on our way to space. If I was off today, I would have had 3 live streams set for today. There was a ULA and there was a Blue Origin rocket.
Falcon 9 has successfully lifted off from Space Launch Complex 40 at Cape Canaveral Space Force Station, carrying the KPLO payload to a ballistic lunar transfer orbit. So we are beginning to throttle down the engines on the first stage to prepare for a period known as max Q.
Watch it just dome around the top bit. There you go.
The highest amount of aerodynamic stresses
Vehicle
on the
supersonic.
view.
That's mad. Oh yeah, it does, definitely.
Max Q.
And there was max Q. So the engines are coming back up to full power.
Nice.
We have 3 events coming up in quick succession in about a minute.
Yep.
First up is
MECO.
That stands for main engine cutoff, followed by stage
Oh, look at that.
separation,
Look at that
SES1,
weather.
which stands for second engine start 1.
Our
Main
hotel
engine
is
cutoff where the first and second stages
somewhere
will
over
shut
here.
down. Main engine cutoff is where the 9 engines on the first stage will shut off in preparation for stage separation. That is where the first and second stages will separate
Oh, yeah.
from one another.
The camera's
first
just
stage will
not
make its way
fast
back
enough.
to our drone ship to attempt its 6th landing, and the second stage will continue
Nice.
with SES1, which is where the Merlin vacuum engine on the second stage will start up.
Here we
continue to
go.
propel our KPLO satellite to its
Look at
desired
that. That's
orbit.
gorgeous. Oh, look at that view.
Those events are coming up in about 10 seconds. For now, we are enjoying some excellent views.
I was
of
going to say,
Falcon
that's
9 during
really
this
nice. Oh, my back's killing me today. Here we go. And MECO now. There you go.
Engine cutoff.
Cool, look how bouncy that is.
Separation confirmed.
Man, second engine
Heads up
start.
ignition.
Well done, Mark.
We saw the confirmation of stage separation and the ignition of the Merlin vacuum engine on the second stage. Coming up in a few seconds, we're going to be looking for fairing deploy. Those fairing halves will separate from the top of the second stage and make their way back to Earth.
Bearing separation confirmed.
Nice.
And off they come. So those 2 fairing halves are now falling back to Earth. Those are
Oh, there they go.
flights
Bye.
for both of these fairing halves, and we are going to be attempting to retrieve them with the help of our recovery vessel, Bob.
Bob. Barber face, he has like a big net and it just scoops out the water.
So we're coming up on T plus
signal, Bermuda.
4 minutes into the mission. We have a couple of views on screen. On the left-hand side is a view of that first stage, continuing to make its way back to Earth. And on the right-hand side is a view of the Merlin vacuum engine. On the opposite side of that engine is the second stage and the KPLO.
All the bits of ice down below just
continuing to
flaking off.
go smoothly after liftoff. The next major milestone for the first stage occurs around the T plus 6 minute and 50-second mark. It's going to be the first
entry burn.
Nominal trajectory.
The first burn is going to be
That's good. That's what we
the
like to hear.
entry burn. This is where we will relight the center engine, engine number 9, followed by engines number 1 and 5. That way we'll have 3 M1D engines helping to slow down the first stage as it passes back into the Earth's atmosphere.
So do you see these grid fins, right? These are huge. Like, I think there's a picture of someone's got one at SpaceX as a table with the glass over the top. Like, it's huge. It's a massive table. Starship is Starship.
Space. It can produce over 220,000 pounds of
so
thrust,
tired.
as opposed to the engines on the first stage, which are optimized to perform at sea level. Those can produce 190,000 pounds of thrust.
Yeah, Starships are like 3 times the size of the Falcon 9 ones.
This view that you see on the left-hand side of the screen, that's actually inside the inner stage looking up. We mentioned those pusher rods, and that we saw a glimpse of those with that video. You can also see some action on the left-hand side of the screen. We see some
Passes of
white
gas.
That is nitrogen from our attitude control system. That
Which Starship's not using.
Those hypersonic griffins that you see on screen, we see 2 of them. There's actually 4 at the top of the first stage. Those help to guide and steer and orient the first stage back to its targeted landing zone. Today it's going to be the drone ship Just Read the Instruction.
Sweet. We should be able to see as well the drone ship is looking like a nice clear landing.
You're about 40 seconds away.
So it's starting to come down now.
Entry burn on the first stage. Second stage continues to perform nominally.
Here we go. See, I think that bit there is that storm or that sort of bit of clouds or whatever.
Stage 1 FTS has saved.
Here we go. So it's basically going to come down between them 2. Here we go. There we go. We have startup.
Those engines have indeed relit. The first stage is currently slowing down before hitting the denser parts of the Earth's atmosphere. This burn is expected to last for about 30 seconds.
And then you'll see like the speed down below the booster. You'll see after it cuts off, it will increase a little bit, but then it will really start dropping. Here we go. So what? 4,800, and now it's going up. But you'll see it will slow down. It will get to about.
In about a minute.
There you go.
We are going to be listening.
Now it's starting to slow down.
For a call out called SECO, that stands for Second Engine Cutoff 1. The engine that you see on screen will shut off its engine.
Oh, we're getting a bit of buffer on the video.
For a nominal orbital insertion.
Ah, man.
The stage is entering its coast phase and is exactly where we want it to be before it relights its engine a little bit later on in the mission.
I don't think we're going to see SECO.
MVAC shutdown.
There we go.
So we did see that the MVAC
Stage 1 transonic.
shut down.
There we go. So hopefully they can now get the booster back. Come on.
Nominal orbit insertion.
Nice, that's
There
good.
was the call out for nominal orbital insertion. The
Oh, here we go.
second
It's
stage
back.
is
Right.
posting for a bit longer.
Where's the drone
and,
ship?
We got views back of our first stage.
Oh wow,
as
look at it
attempts its
pitching.
sixth landing on our drone ship.
landing burn.
Oh, there it is, right under the grid fin, that side. The left one by me. It's just underneath. There it is, you can see it wobbling. Here we go. Oh,
You can start to see the drone ship.
cool, that's really doing work, isn't it?
On landing, like deploy.
1, 2, 3. Oh, okay.
Sometimes the video cuts out. We'll wait for confirmation of whether or not the first stage was able to land.
That did look. I mean, they've been looking
But
really.
for now, we know that the second stage is in its coasting orbit. And there is that second stage with the Merlin vacuum engine off. And that's a view of the KPLO payload.
I don't know. Lately the boosters have seemed to be like.
Expected loss of signal. Keep.
They seem to really be moving about lately on the landings. We had this last time though that I live streamed. The
We
booster.
haven't heard confirmation of the first stage, whether it was able to land for the sixth time. But the second stage is now embarking on its coast phase between the first and second burns of the MVAC engine. After the coast phase,
there we
we'll light
go.
that MVAC engine for a second time, a bit after the T plus 34-minute mark.
Stage with landing confirmed.
Hey, there we go.
And
We
before
got it.
head off, we did get confirmation of the first stage landing.
Nice.
That is the 127th successful recovery of a Falcon 9 first stage and the 110th mission flying a rephone booster, which includes both Falcon Heavy and Falcon 9 missions.
Nice.
So we'll see you back here in about 20 minutes. In the meantime, enjoy the space tunes.
So they landed it. It was very. It didn't look like it was going to slow down in time, and the grid fins were moving a lot, like seriously a lot. But yeah, so I really wish this was during the day because I would have streamed this whole thing. Ah, there we go. We got a picture of the booster. Oh, it's a little bit off the center. Doesn't look too happy, that booster. But yeah, I am going to end it there, guys, because I do have work. And, I do have work tomorrow, so I do need to get Peter Griffin's. But yeah, I need to get some sleep. So yeah, thank you very much everyone for watching. I'm going to turn that audio off for you guys. So thank you very much for watching. I'm Lee. Fly safe, land safer.